Hey there, Dean Stevenson here, and in this video, I'd like to talk about how we can perhaps avoid the quote-unquote math magic that we see when we flip using algebra tiles, and rather play off the intuitive sense that students already have by thinking about takeaway as a way to help them see why the negatives quote-unquote flip. If you have questions or ideas about this video, feel free to shoot me an email. My email is right here. It's deanlstevenson@gmail.com, and thank you for watching. To lay the foundation, what I'd like you to think about are the two expressions that are on the screen. 2 take away 5 versus 2 plus negative 5. And I'd like you to think about how those are similar and how those may be different and how you would model those using algebra tiles. So if you'd like, take a second to pause the video, and then when you're ready, come back and we'll talk some more. So let's start off by using the way that I believe more people who use algebra tiles use, which is the bottom expression, 2 plus negative 5. So the first math magic that we talk about when we're using algebra tiles is that when you see 2 minus 5, think about it as 2 plus negative 5. So to do that, we start off by taking 2 positive 1 tiles, putting them onto our expression map, and then because it's plus, we throw the 5 negative 1 tiles on there. So now we have 2 plus negative 5. And then to get to our final solution, we look for 0 pairs. So we match up the ones that we can with the negative ones. And then we use those 0 pairs since those net 0, and we take those away. And we're left with the final answer, which is negative 3. And so this approach works really well, and it helps students kind of see where that kind of why a minus is really just adding a negative 5, and that's fine. But it does have a little bit of a gimmick to it, if you ask me. So now let's look at the same exact idea, but with the natural way that it's written, which is 2 minus 5. So when we look at 2 minus 5, if we think about that as, I'm going to use the term takeaway, but let's go with 2 take away 5, and let's start off, we start off with 2 tiles. And those 2 1 tiles represent our 2, and we need to take 5 away from those 2. But anyone, and children have learned this from a young age, you can't take 5 from 2, so we need to have 5 to be able to take away 5. Well, what we do is we reverse engineer using 0 pairs. So we bring 5 into the expression mat by bringing in 3 0 pairs. So now notice we have 5 positive 1 tiles, we have 3 negative 1 tiles, but really what we have on the screen is 2. So we haven't done anything yet. We still have 2, we're just drawing 2 in an equivalent way. And that equivalent way is very specific so that we now have 5 positive 1 tiles that we can take away. So we're going to take away 5 now that we have 2. And when we do that, we're left with negative 3. So we have done 2, we started with 2, we take away 5, and we're left with negative 3. So by using takeaway, we arrive at the same answer, but now we're still keeping it the way it's written instead of kind of using the pluses of minuses and saying that's the same thing as subtracting. There's no kind of gimmick going on. So that's kind of a basic idea of what we want to think about. And now we're going to talk about that in a much more complicated example where we're kind of talking about polynomials that are being subtracted. So again, we're going to go through this both ways. We're going to use the pluses of negatives and kind of talk about why that seems a little bit more gimmicky than the other approach of really just thinking about takeaway. So when we have a polynomial or an expression and we're subtracting another polynomial expression from it, we start off by putting the first polynomial on our expression map. So you'll notice we have 2x squared, we have 3 positive x's, and we have 6 negative 1s. So that's 2x squared plus 3x minus 6. Now we need to take away from that this bottom expression. Now anyone who I've seen explain this problem using algebra tiles, what they tend to do is they say, okay, first thing is to put the expression onto the map. So put the second expression on the map. Boom. It's a negative x squared, a 2x, and a 4. But now remember, it's a negative of that expression, so we need to flip, because when we see negatives in algebra tiles, it means flip. So we have to flip that whole second expression. Boom. The whole expression gets flipped. And now because we flipped the expression, it's really adding. So now we can just add it like we did before. So we bring our like terms together and we find our 0 pairs. So we notice we have no 0 pairs in the x squared term. We have 2 0 pairs in our x term, and then we have no 0 pairs over here. So we take out our 0 pairs, and we arrive at the solution, which is that it's 3x squared plus x minus 10. Correct answer, everything's cool, but something just feels a little bit like a trick. Like, why did we put an expression on our expression map and then flip it, and then we're allowed to add it? And that is the part that really bugs me, I think, about this approach. So let's think about this from a takeaway perspective. So if we want to use the takeaway approach, we come back to our original expression and we first rewrite the first piece of that expression using our algebra tiles. So we draw ourselves 2x squared plus 3x minus 6. And now we want to take away from this a negative x squared, a positive 2x, and a positive 4. Well, we can't take away a negative x squared because there is no negative x squared here. So just like we did when we were just dealing with integers, we're going to introduce a zero pair so that we have a single negative x squared we can take away. So notice we've now introduced a zero pair. We now have a negative x squared that we can take away, but we haven't changed it. It's still just 2x squared. So now we have 2x squared, and we're going to take away the negative x squared. And notice that leaves us with a positive 3x squared. From there, we look at the second term. And that second term, you'll notice we have 3x, and we need to take away 2 x's. So we don't need any zero pairs to do that. We already have 2 x's on our screen, so we can take them away. We take those 2 positive x's away, we're left with a single x. So now notice we've done the 2x squared, take away a negative x squared. We've done the 3x, take away the 2x. Now that's all that's left is we have a negative 6, and we need to take away a positive 4. But we don't have a positive 4 to take away, so again, we need to introduce zero pairs. This time we need to bring in 4 zero pairs. That way we have a positive 4 that we can take away. So we're just going to take those suckers away, and boom, we're left with a negative 10. So notice, through takeaway, we've now gotten our simplified expression, the exact same one we had before, and it is 3x squared plus x minus 10. But we didn't have to utilize any gimmicks or tricks to get there. We just drew on the student's intuitive understanding of takeaway, and we also used zero pairs. And if you plan on using algebra tiles throughout your Algebra 1 curriculum, you know that introducing zero pairs is something that's super important. And when you get to units such as factoring, then being able to have students feel comfortable introducing zero pairs will be very helpful to help them factor certain expressions when that is a necessary piece of the puzzle. So I hope these thoughts have been useful to you, and I hope this maybe helps you reconsider how you work with your algebra tiles. And if you have any thoughts or questions, feel free again to contact me. My email was at the start of the video. And thanks again for watching. Have a great day and good luck.